Hello, welcome to Cerp TV. Today we are going to be having our very first class on differentiation. Coming up in our classroom today, introduction to the rules of differentiation. This is Cerp TV and you are highly welcome. We will be right back. Welcome back. Rules of differentiation, number 1. Now, the very first rule we are going to talk about in differentiation, whenever you are going to differentiate the power function, we call this the power rule. When you differentiate x to the power n, it simply gives you n x to the power n minus 1. Exactly what are we saying? When you differentiate a power function, let's assume that you have been asked to differentiate, we can just say x cubed. Now for you to differentiate this, the only thing this rule is trying to say is that you should take the power and bring it down. Now when you do that, you're simply going to have, the power here is 3. You bring it down here. So we simply have 3, and then we repeat our x. 3 minus 1 gives me 2. So I simply have 2. And that's basically the platform upon which differentiation drives. Another example, this is example 1, example 2. When you have to differentiate with respect to x, let's say x to the power minus 4. It doesn't matter whether the power is positive or negative. All what we are interested is to know what that power is. So we simply have this being equal to, bring down your power, which is negative 4. So I have negative 4. Then I have my x. I'm subtracting 1. Of course, we have negative 4, negative 1. And of course, negative 4, negative 1 will simply give me negative 5. So this simply becomes equal to minus 4x. Okay, we continue. Now, minus 4 minus 1 simply gives me minus 5. So that becomes the answer. Okay, now imagine that you were asked to differentiate d by dx, and then you're having x to the power, let's say 7. What will your answer be? You take 7 and bring down. That is the basic rule of differentiation. See, to differentiate x to the power n, take n and bring down. That's what you're seeing here. And then you now have, you subtract 1 again from it. Is that okay? Okay. So we now have this being equal to, you take 7 and bring down, which now gives me 7. I write x again, 7 minus 1. So I can have 7 minus 1 here. And at the end of the day, I simply have 7x, 7 minus 1 is 6. So basically, that's how differentiation runs. Bring down the power, subtract 1. Bring down the power, subtract 1. Is that okay? Beautiful. Now, this will also work. It doesn't matter whether we have a rational power or not. Like maybe somebody has asked you to differentiate with respect to x, and then you have x to the power 1 over 4. The same thing, it's simply going to be equal to, you take this 1 over 4 and bring down. So I have 1 over 4, and then I have my x, then I have 1 over 4 minus 1. Let's do something here. 1 over 4 minus 1 will simply be equal to this 1 over 1. LCM is 4. 4 divides 4 to give me 1. 1 times 1 is 1. 4 divides 1, 4. 4 times minus 1 is minus 4. 1 minus 4 is negative 3 all over 4. So at the end of the day, this simply gives me 1 all over 4, and then we have x to the power negative 3 over 4. That's good. So this is the simplest way we can introduce the theory of a differentiation. You take your power, break it down, and then subtract 1. Once you do that, you have differentiated. Voila. Okay. So what if let's just take one more example for this rule. What if they asked you to differentiate with respect to x? You see the way I'm pronouncing it? Differentiate with respect to x, or you say d by the x. D by the x. Maybe we have x to the power 10. What will it be? I'll carry this guy and bring down 10. Then I'll rewrite my x again. 10 minus 1 gives me 9. And that's the end. Bring down the power and subtract 1. Once you do that, you have differentiated. Okay. So, rule number 2. Now, the second rule for differentiation, whenever you have to differentiate with respect to x, and then you have, say, ax, your answer will simply be a. Whenever you have to differentiate ax, whereby the power is simply 1, your answer will simply be a. For instance, number 1, if you asked me to differentiate 2x, I don't have to do anything. This is ax, my answer, because of course the power here is 1. When you follow from the first rule we just did, you will discover that 1 minus 1 gives you 0. So this variable is going to disappear. So we'll simply have a. So this simply gives me, when I differentiate 2x, I simply get 2. Number 2, if you differentiate with respect to x, minus 5x, you know what your answer is going to be? Simple. Minus 5. Whenever I'm differentiating ax, my answer simply becomes a. Voila. So simple. Very, very simple. Okay, when you're differentiating with respect to x, 1 over 3x, you don't have to do anything. Your answer is simply equal to this guy here. This is ax. So we simply have 1 over 3. What if we were differentiating with respect to x, and then we have pi x? Pi x. Simple. Pi is a constant. So my answer simply becomes pi. And that's it. So, we can clean up now. So generally, whenever you differentiate ax, you simply get a. Okay, let's take 1 or 2 more rules and then we end our class today. Our next video continues to elaborate more on the rules of differentiation. Whenever you differentiate a constant, this is now rule number 3. When you differentiate a constant, let's say that constant is c, you simply get 0. Whenever you differentiate a constant, your answer simply becomes 0. For instance, if I differentiate with respect to x, 2, my answer is 0. It doesn't matter the constant. Number 2, if I differentiate with respect to x, 10, my answer is simply 0. As long as it's a constant, when there is no variable attached to it, my answer simply becomes 0. If you had to differentiate with respect to x, and let's say you're having minus 5, your answer is simply 0. Voila. So that's clear. Whenever you differentiate a constant in differentiation, in the rules of differentiation, or in calculus, your answer you simply get 0. I hope that's clear. Okay, now we go on to rule number 4. Let's quickly look at rule number 4. I think we are going to end our class with rule number 4. When we differentiate with respect to x, and then we have x to the power n. It's very simple. This is simply going to become equal to, this a stays here, this n will come down and multiply this, so we have a n, then we have x to the power n minus 1. That's the rule. You know what we are trying to say is just try to imagine that you have to, let's look at example 1. If you were to differentiate with respect to x, and then you have 5x cubed. So that's what we are talking about. Ax to the power n. It doesn't make any difference. All what we are going to do, this 5 will stay here, and then this 3 will still come down. So we have 3, then we have x to the power n minus 1, which is 3 minus 1, and 5 times 3 is 15. So we have 15x, 3 minus 1 is 2. Is that clear? So differentiation is very, very simple. Most especially when you get it right from the very beginning, you just fall in love with it. Okay, so what if you were asked to differentiate with respect to x, and then we have 1 over 3 x to the power 1 over 3. Okay, this simply becomes equal to, this is 1 over 3, the 1 over 3 will stay here, and then it's multiplied by the power, this power has to come down, multiplied by 1 over 3, and then I have my x to the power 1 over 3 minus 1. That's what the rule is saying. X to the power n minus 1. Beautiful. So 1 over 3 multiplied by 1 over 3 simply gives me, so this becomes equal to 1 over 9. Now when I come to evaluate 1 over 3 minus 1, it's kind of confusing, so I need to create space somewhere to be able to do that. So let's see what 1 over 3 minus 1 gives us. 1 over 3 minus 1 over 1. LCM is 3. 3 divided by 3 gives me 1. And 1 times 1 is 1. 3 divided by 1 gives me 3. 3 times negative 1 simply gives me negative 3. So I have negative 3. 1 minus 3 gives me minus 2. So I simply get minus 2 over 3. So this 1 over 3 minus 1, we have just shown that is negative 2 over 3. Voila. So simple. So that's differentiation basically. Always remember that in differentiation, you bring down your power and then you subtract 1. You bring down your power, you subtract 1. You bring down your power, you subtract 1. Is that okay? Now, we continue to make it more and more easier. Okay, what if you were asked to, like say, let's say differentiate with respect to x, and I have 4x to the minus 3. This is very simple. All what you're going to do, this is your a, just look at what the rule is saying, carry that to your n and bring down to multiply this a. So I may not even have to, at this level, I may not even have to write so much. Minus 3 times 4 will simply give me 12. Minus 12, sorry. So I have negative 12, and then I have my x. And then minus 3 minus 1 is minus 4. So I simply have minus 4. And that's the answer. My first class on differentiation. So we are trying to make it simple so that you can comprehend, you can understand it very, very well. Is that okay? So that's that. We solved 2 more problems and then our class for today will come to an end. 2 problems. Number 1. What if I asked you to differentiate with respect to x, and then I have x to the power 1 over 8. So this is very simple. I'll take 1 over 8 and bring down. So I'll simply have 1 all over 8, and then I have x to the power. Subtract 1 here, 1 over 8 minus 1. Saba. And then, let me quickly come here and check what 1 over 8 minus 1 over 1. LCM is 8. 8 divided by 8 is 1. 1 times 1 is 1. Minus 8 divided by 1, so we simply have 8 here. So I simply have minus 1 minus 8 is negative 7. So I simply have negative 7 divided by 8. And that's the answer. So this simply becomes equals to 1 all over 8 x to the power 1 over 8 minus 1 simply gives me negative 7 all over 8. Thank you. So that is basically our first class on differentiation. In 3 or 4 days time, I'm going to be coming your way with Introduction to Differentiation Part 2. Make sure you don't miss it. Thank you so much for coming around and for tuning into Cerp TV. Please, just in case you have not subscribed to Cerp TV, you can do that right now. Do have a wonderful time. Bye-bye.